And we're live. Hello, it's Tuesday, June 28th, 2016, and this is the 11th installment of Usenix's LISA Conversations. I'm Lee Damon, a senior computing specialist at the University of Washington.
And hello, I'm Tom Limoncelli, a site reliability engineer at StackOverflow.com.
And I'm Kat Okita, senior security researcher at Akamai.
If you're watching live, we'd love to have your questions. You can submit them using the Q&A button. You might need to click on the 3x3 box in the upper corner. At a guess, it's this corner up here to find the Q&A button.
So for the last 12 months, LISA Conversations has brought you speakers from Usenix conferences to discuss their presentations and find out what's new. In our last episode of the season, we'll be talking with Russell Pavlicek, now writing a book about unikernels for O'Reilly, in between writing articles on topics and searching for a new position. So Russ gave a great talk at LISA 15 titled The Next Generation Cloud, Unleashing the Power of Unikernels, and that's what we'll be talking about today. Russell, welcome to the show.
Well, it's great to be here.
We always open up with these three questions, so let's get up started. Warm-up question. If you could explain at a high level what your talk was about. We're talking, 30 seconds high level.
Mm-hmm. Okay, unikernels, for those who may have heard the term but don't know what they are, consider embedded programming applied to the data center. As you're well aware, probably all around you as you're sitting watching this webcast, there's a whole bunch of little devices. And many of those little devices have little chips, and on those little chips are little programs that do one thing and one thing only. There's no operating system. It's just enough to get the job done. A unikernel is that concept applied to the data center. We want to see, for certain things, the removal of an operating system, and instead make it small, fast, light, and more secure.
That was more than 30 seconds.
Sorry.
Very succinct description, all the same.
Yeah. So what was the reaction to the presentation?
It was actually tremendous. I've been doing presentations on unikernels for the past 18 months or so, and the last 6 months, or 6 to 9 months, I'm getting a uniformly tremendous response from people. People want to know about this, and it was no different at LISA.
So on the assumption our viewers have had the opportunity to watch the video that's published by Usenix and linked in the show notes down below in the doobly-doo, can you have any updates that you want to give, brief updates that you want to give?
Yeah, probably the number one update is that if folks have been watching the news at all, it has to do with Docker. And Docker bought in the end of January a little company known as Unikernel Systems. And Unikernel Systems had the combined brain trust from about 3 different unikernel projects, not completely, but some very significant people, and they all went over into Docker. And so I really expect to see something very interesting come out of that. They've already demonstrated Docker controlling unikernels. As far as I know, it's not productized yet, but we'll wait and see. I think it's looking good. The other basic things that I would mention is that Include OS, which is one of the ones I mentioned, just had a release. They're up to 0.8. They're almost stable, in their own words. And HalVM, which is one of the oldest unikernels, is preparing for a version 3 series with all sorts of new updates. So that's really quite cool. And then about a month ago, I ran across something called Unique from EMC, and I'm still trying to get the details on it. And if there's anyone from EMC listening, I'm still waiting for the paragraph that I need from you folks. I want to add it into the book. But they apparently are working up some way to more easily transition an existing application into a unikernel. And I'm very interested to see what they have done in that regard. I'm still trying to get the information.
Cool. Tom, are you there?
Yeah. Well, the next question that we usually ask is what's new, but I think we covered that. I think tell me about the book. That's very exciting.
Yeah, it is very exciting, actually. It's actually from O'Reilly. It's going to be an ebook, so as I understand it, it's going to be free. So if people want to know more, that's a good thing to do. I am literally hoping to put it to bed this week. In fact, I've been trying to get the final edited draft back to my editor. So it's scheduled for release later this summer. So people who want to know more, who want to tell others about unikernels, that's probably a great place to go, since it shouldn't cost anyone anything, and it will contain everything that I have ever talked about, plus a few new things that I began to mention here earlier.
Right. So that sounds really exciting, and as an author, I want to congratulate you on the pending publication. I guess one thing that I was thinking about this afternoon was I've never used unikernels, and I was thinking, how would I get started if I wanted to play around with them?
Yeah, getting started with unikernels is one of those interesting things. You first would probably want to focus on a language that you're comfortable with, and then see which unikernels support what. It's very interesting that in the unikernel world there are many different approaches. It's still a very new sort of technology, so the rules are a little flexible, and different people look at things different ways. But you've got some things, frankly, this unique project that's coming out of EMC that they've open sourced and so forth, I think like less than a month ago. That looks really promising as a starting place for people who just want to get in and dabble. Then there's things like OSV, which is kind of a fat unikernel. They look at things a little bit differently. That's meant to be more of a drop-in sort of technology. And originally it was for Java war files and things like this was the way they were playing it. But as some of the members of that team were telling me, they can run just about anything. But that would be an excellent place because, frankly, it's already sort of fully augmented. So, if you follow their instructions and you drop something in, you might get something running relatively quickly. And then from there, it's a question of what languages you want to work in or what application you're trying to port, and then trying to figure which unikernel will give you the best approach. Because some of them are in type-safe languages, like Haskell and Camel and all this sort of stuff. And that's great if you're working in those areas, but then there are other ones that are much more flexible as far as their bindings. OSV being one, and RumpRun is tremendous. That's anything that's POSIX-y should be able to fit into RumpRun.
So from a system admin perspective, this is all sounding kind of scary to me because you need to know what language you want to use. You have to figure out which one of these 15 different unikernel things you want to use. Do you have some advice for me for looking at it and going, hard thing?
Well, from an admin perspective, at least none of the work I've done, the admin goes around creating the payload. The admin loads up the payload. And the net result of a unikernel is a VM. And it happens to have certain qualities to it in that it's normally very small footprint-wise. I mean, I found out, by the way, for folks who attended the Lisa talk, I was talking about the Mirage people have a DNS server that I think I was quoting the old number of 449 kilobytes is the image size. I got corrected about a week ago from one of the Mirage guys that they're down to less than 200 kilobytes, and that's for the full VM image size. And so basically, you drop that image into a virtual machine and you power it up. And so from an admin point of view, quite honestly, it's no different than starting any other virtual machine. Where it is a little bit different is on the development side, where you're actually doing, rather than a native compilation, you're doing a cross-compile. And you do a cross-compile into something that doesn't exactly exist, which is this self-contained unikernel.
So as a sysadmin without developers here, I'm running services. I have a couple of dedicated boxes that provide DNS and DHCP and et cetera, all in one one managed machine. How can I take advantage of this if I don't have the developers to do the cross-compile and build?
Right. Right now, you would probably go to one of the projects and see if they have any images pre-built available to you. That would be the easy thing, and that would probably make the most sense, quite honestly. It's still very early in the game for those libraries, but unikernel.org, which is kind of trying to become the hub for most activity in the unikernel world, is trying to put together a library of such things so that you can just do exactly that. You want to pull down a unikernel, have a DNS server, whatever it is, you find it, you load it, you go. As far as I know, they haven't come out with that library yet, but that's on the thing that one of the things that they're working on. So it's still very early in the game from an administrator standpoint. It's still in the developer's mindset phase.
So wearing a security hat for a moment, what kind of mechanisms are built in so that I can know that whatever I'm pulling down from by way of a unikernel is actually going to be safe, sane, and reasonable?
Well, safe, sane, and reasonable is one of those interesting things when it comes to a unikernel, because a unikernel contains exactly whatever a unikernel needs to contain and nothing more. So if you need particular security augmentations, it's a question of whether or not the developer put them in. Of course, from a security aspect as well, if you're using something that is Xen-based, for instance, you can still use Xen security modules because it's just a VM. And the Xen security modules, for people who don't know, is basically SE Linux applied to a virtual machine architecture. So you can actually lock down things actually a lot more easily than you can under Linux, for the simple reason that when you apply SE Linux to a full server, you've got all these various processes that are out there in the supporting role. And you've got to be really, really careful that you don't set a rule that's going to keep one of those processes from doing its work. Well, in a unikernel, there's one process. There's only one thing going on. And so if that thing shouldn't be able to touch a disk, you shut that down. You just make it impossible. So there's all sorts of things that you can do from the VM level using tools like XXM. But as far as the augmentation of the unikernel itself, as far as the implementation of the unikernel itself, you put into it exactly what you expect to use in it. And from a security standpoint, let me just throw this in too, because people seem to keep asking this question. I want to make sure they understand. When you break into, say, an Apache web server or something like this, someone hacks in, they find a way to do something nefarious. They're trying to drop into a shell, or they're trying to run a program or whatever to get something back that they're not supposed to see, or to do something they're not supposed to do. The unikernel doesn't have any of that. So, I mean, there isn't dropping to a shell. There is no shell. There isn't calling, grep or tail or, pipe. No, there's none of that. It doesn't exist. So even if you manage to exploit a flaw in the code, that's one hurdle. The bigger hurdle is trying to be able to get something useful out of that from a cracker's standpoint without any tooling whatsoever. So you basically have to sort of be able to move it into memory without the aid of any sort of coding mechanisms at all, which is challenging. I mean, it's not impossible, but it is not simple by any stretch of the imagination.
The downside to that is it makes management really hard because, again, sysadmin not dev. I have no tools now. Why isn't this name server serving? I have no way of finding out what the problem is.
Well, actually, it's a question of what tools do you need. There are certain tools, once again, at the hypervisor level, particularly inside the Xen world, which is, for people who don't know, I spent 3 years as the Xen project evangelist prior to 6 months ago when I got laid off. But there are a number of tools that work at the Xen level to allow you to do some introspection. In fact, if you go to xenproject.org in the video section, I think at last year's Developer Summit, there was a very interesting video that's out there that talks about doing VM introspection from the hypervisor level. So tools like that at the hypervisor level are definitely available. From a debugging standpoint, there's a question of, well, what tools do you really need? And you make sure that you have that brought into the actual stack itself. One of the things I hear people say is like, oh, you can't debug a production unikernel. Well, you know, I've been in this industry for 35 years, which is a really staggering number for me personally. It's like I don't like to think I'm that old, but yes, I am. But I spent 20 of that, give or take, working with federal government customers, Fortune 100 customers, these big companies, and all that time I've never been permitted to debug a production machine. The rule was if you had a production failure, you grab the logs, you grab the, you know, you check the network packets and all this sort of stuff. You bring this all over to development, you fix, you redeploy. Now I know that there are some models today that you know, that are more flexible about that sort of stuff, but in the unikernel world, that's kind of the way you still want to go with your debugging process. And you know, all I can say is it worked real good for me for 20 years. So I don't think it's impossible at all, like some people try to make out.
So
not to, go ahead,
sorry. All right, I'm going to stop you here, Tom. So, in terms of security, is this going to be dependent on what the dev actually puts into your unikernel?
To a certain extent, yes, and to other extents, like I said, there is an inherent quality to unikernels which I think, frankly, are going to be potentially superior to what we're using now. One of the problems that we have now inside our normal payloads is you got things like SE Linux, which is great. It's terrific technology. But if I had $1 for every server I have seen deployed in production where the you know, where the admin said, I was told to get this up now, I don't have time to get this configured, I'll get back to it later. You know, if I had $1 for every one of those instances, I'd own an island somewhere off, you know, Bermuda, you know, because it happens all the time. And the problem is, if you look at the statistics of what's happening security-wise in the internet, the number of breaches, particularly in the last like 18 months, have gone through the roof. We have some huge, huge problems here. We have to change the nature of the game. And I think that if we can take if we looked at even just those edge servers, the things like the web servers, the app servers, some of these things that are talking to people and that the nefarious among the internet world are targeting first, if we could use them inside a unikernel sort of situation, they may be able to initially break it, but they're not going to get anything from it. Because the connections aren't there. I mean, there's no password file. There's no connection to another database or something else that they may be able to, you know, wiggle around inside a traditional server, because it's just not there. There's only what's needed to get the job done, and there are no tools. So, so I contend that is at least worth a serious security evaluation, and we're at sort of discussion about this. But I'd really like to see how this plays out. I think this is going to be a major improvement for what we have right now.
Mm-hmm.
So go ahead, Tom, and then I have a QA question.
Okay, so what you're saying reminds me of you know, what one issue that we have with like Docker images, and also just actually any source code, is the problem with reproducibility. I mean, we've all been at a company where a developer leaves and all of a sudden no one can rebuild a certain bit of code. We've mostly gotten away with that, gotten away from that with, you know, source code repositories and that kind of thing. But one thing that a lot of people had to learn the hard way is with like Docker images, you don't accept the image from the developer, accept the, the Docker file and the various things that make the image, put it through the CI system, and so no one builds the binary because it's the automated CI system that builds it. And I would imagine it would be the same thing, or at least there's analogies here for unikernels, that you probably want to have some demarcation where, you know, up until here it's all source, and then the CI system builds the VM, and that's what actually goes into production.
That certainly seems like a reasonable concept. Once again, we're so early in this thing that I'm not aware of anything that does that automatically. I don't know whether that unique system from EMC begins to play with that, but I would definitely expect to see more things along those lines real soon now, because this thing moves real fast. And one of the things I just want to mention too is that, you know, every time I give this talk, I have to sort of do a quick scan to see what's out there, because the number of things that tends to occur in the unikernel world in real time is just it's incredible. There's a lot of stuff going on out there. So yeah, this is one area that I expect to see a lot more real soon now.
Mm-hmm.
So I'm going to insert a reminder that we have a Q&A button in the probably that corner there. Please feel free, if you're one of our live viewers, to hit that button and submit a question. We have a question from Florian Hegel. I hope I'm saying that correctly. And he asks, how can we make sure that knowledge and practicability, okay, I like that word, catch up to the potential of the technology? When Xen went really public, say version 2.0.x, there was a full-blown guide. That was in 2005, and enterprise virtualization became ubiquitous only 3 years later. Will the unikernel world catch up to this?
I think so. That part of that effort, it comes with the whole unikernel.org website. And that's, I think, part of the reason why that was birthed to begin with. Amir Chowdhury and some others, trying to get that hub of information. And I think we will begin to see the birth of some of these more generic how-to guides and whatnot. So far, individual unikernels are trying to do their piece. In fact, one of the roles that I have in all this, just to make everyone's absolutely clear, I'm not a unikernel developer. I'm one of the few people running around talking about unikernels who isn't one, because my value is that I can stand back from the individual project and say, take a look at the mass here, take a look at what's going on, take a look at the movement, more than a lot of these people do, because they come around, they talk about what they've done, which is terrific. But now we're starting to get more of the big picture mixing in with the individual cases. So I think this is in development, but I think unikernel.org is going to be a hub for a lot of these things. I think we're going to see books. I think we're going to see all sorts of interesting guides. But like I said, still a little early, but you know, stay tuned. This stuff is roaring ahead.
Tom, did you have another question you wanted to ask, or shall I continue?
Go for it.
Since I interrupted you earlier. Okay. So one of the, I obviously have watched your video a couple of times because I don't understand unikernels. I don't claim to understand unikernels. I also don't claim to understand containers because I don't have a site that needs or uses them. Can you give us a very brief explanation of the difference between these two concepts of unikernels and containers? Because like I said, I don't really understand how either of them works.
Sure. And I'm no container expert, but I know enough when it comes to this question. Containers, you start with an operating system, let's say Linux, and it's got all of that, all of those files, all of those utilities. You've got a working kernel, you've got all memory management, all these things, all there on the Linux-based system. And in the container world, rather than using a full virtual machine which replicates all of those things, you end up with sort of a shared namespace so that you can borrow from that host, that Linux host, everything you need to run, and then you layer on top of it the particular things that make that container useful. So the net result is that when you want this thing to start, it starts like this, because the host operating system is already there. It's lightweight. You don't have to replicate 3,000 utilities like on my Ubuntu laptop. They're already there. So you're reducing space, you're reducing startup time, you're starting the program you want to start in this little bucket, and it executes, and maybe it goes away right away or whatever. That's very fast, it's very small, lightweight, it does a lot of things really well. I think containers are really neat technology. Unikernels goes a little bit different path, and it says, why do we even have this operating system here? Because if that Linux host is out there, and you've got tons and tons of these little containers floating around on it, if perchance some nefarious do-batter comes in and does something to that base operating system, then all of these containers are now at risk. Why not just put the application code sitting on the hypervisor layer, and not even have all of these places where you know, the nefarious people can try to exploit. We'll just go right into that level. And in fact, there's even some unikernel technologies right now that will allow you to run with limitations on metal. Really wanted to do it that way, which makes sense from an embedded perspective anyway, because that's where embedded actually hangs out. You know, it's this notion that we're going to get rid of the operating system layer, and instead we'll include just enough operating system functions in a library to do whatever the application needs to do. That's it. That's all that's there. So size becomes minuscule. As I said, you know, a DNS server, and I think it was 188 kilobytes image size. If you go to Erlang on Zen.org, their website runs on a unikernel, and you push the little escape button up inside the upper right corner, I guess it is, and they allow you to look behind the covers, and generally that runs in about like 12 megabytes of space to run this fully operational web server. You know, this is cool. This is different, and you know, you don't have the attack surface. And there's an excellent talk by George Dunlop out on the zenproject.org site on the videos, once again, Developers Summit or something like this about a year and a half ago, where he actually looked at the attack surface between, you know, just 3 months of exploits from the Linux operating system versus 3 months of exploits from Zen. And there was like more than an order of magnitude with the difference. So the idea is, if we can take all that stuff out of there, we can make it more secure. We can get to these highly dense systems where, you know, at last I heard the Zen team was looking to try to get 2,000 to 3,000 concurrent unikernels on a host at the same time with linear scaling. And that's, you know, that's a thought we've never had before in this industry, because, you know, up until a few years ago, if you got to 10 VMs on a hypervisor, you know, you thought we were greater than, you know, sliced cheese. But now we're looking at multiple thousands. So if there's a game-changing thought going on.
That's great. Are we seeing? I know that this is all very new, though. Well, it's new depending who you talk to, of course. I mean, the ACM had that groundbreaking paper, I guess 2 years ago. What's the uptake like in the corporate world? Are we still in the experimental mode, or are we starting to see success stories in the corporate world?
Well, in the corporate world, the thing that astounds me, and it does astound me, I've been pushing open source for 21 years now, so I have seen a lot of things in development. But what astounds me is, here you have a technology that probably a number of people who are listening to this, you know, are just trying to find out what it is. And this happens all the time when I give my talks. Most people have no idea. They just know that this is something that sounds like it's important. They want to know what it is. At this early stage of the game, the number of corporations that have gotten involved, and I have a little cheat sheet here, so let me read from it. IBM, NEC, Ericsson, Docker, and Microsoft, and EMC, which I didn't put down. They are all active. I mean, several of these have unikernels, others have things that go inside the unikernel ecosystem. This, to me, is fascinating that at this stage of the game, when we consider this sort of a green technology in terms of maturity, there are so many major players jumping in to start work. That's astounding to me. I've never seen that in this industry before. You always had, you know, a couple of champions, and then everyone else comes later. This list, you know, this is an amazing list. So
there's still opportunity for interested people to get in on the ground floor.
Oh man, yes, the opportunity is massive, because you know, there's still so much work going on, so much to do, so many problems that need solving when it comes to the administrative side and all this sort of stuff. The cloud, you know, things like OpenStack. You know, if you start having, you know, something which I call transient microservices, which are just things that literally appear when they're needed and disappear when they're done. It's like, how do you manage that in the cloud? You know, we haven't had that problem before, because up until now, VMs were, they were slow. Someone have to say start that, and they have to wait for it to start. It may take seconds, it may take a minute, it may take a few minutes if it's a database. And then when it's done, then you say shut it down. Well, with a sort of a unikernel-based transient microservice, the entire life of the service may be a half second. You don't want to wait for anyone to say go. You want that thing to appear when it's needed. You want it to do its thing, and you want it to go away. And in Internet of Things, in particular, when you've got the potential of every button and every switch making something come to life, you don't want things sitting there with their fingers in their ears waiting for things to happen. You want things to be born, to act, and to die. And you want to somehow do it inside a reasonable orchestration sense. And that's a problem that still has to be figured out, as far as I know. I haven't been in touch with so many of the OpenStack sort of people, so maybe there's already a lean on that. But that's one of the things that's got to be coming. And I know it's coming. It's just a question.
So speaking of the transient microservices, one of the things I'm really kind of wondering is whether you could actually leverage those in some type of an object capabilities type model. And I'm also wondering what kind of a communications model you might be looking at between different microservices.
Frankly, as far as the communications and things, I mean, as far as I understand it, I'm not a microservices guru. Okay. The concept, I think, still remains pretty much the same of whatever people are doing now. It's just a question that you need something somehow that needs to report to. So I mean, you may, instead of writing things to a log or going to a database, you may want to throw it out onto the network for something else to monitor and report on and make sure that it's functional and so forth like this. So I mean, there's techniques that still have to be worked out, I think, on that level. And from a transient microservice standpoint, this is even greater than the unikernels, okay? So, but it's out there. In fact, if you go once again to Erlang on Zen.org, they have a demonstration which they call Zerg, Z-E-R-G, which they refer to as the zero footprint cloud. I think that's what their use case is. And they've got use cases on their site that explains it more. And it's that concept of the Christmas retail problem. Okay, on December 10th, some big box store is going to be selling 59-inch plasma TVs for $49.95. So at 11:59 p.m., you have 3 million people sitting there waiting to press the button to get one of them. You don't need any servers waiting on all these people beforehand because there's no traffic. When they press the button, we need, if there's 50 million things, we need 50 million, the capability of answering these 50 million requests. And then, when the transaction is done, we want them to go away. So that before you need it, there's nothing there. After you need it, there's nothing there. That's kind of the transient microservice concept in a nutshell, in a slightly different context. How do we track these things? How do we get the communication models? If you got an idea, jump in. It's time, and people who want opportunities. This thing is rife with opportunities because there are problems that we've never had before in this industry, never. And now we got to think them through and say, well, how's the best way of doing that? And so there's plenty of room for people with inventive minds to stand in there and say, I know how to do this. This is easy. I got it. And you can make history that way. So
cool. So let me turn to a more technical question. I'm one of the problems that I'm having trouble wrapping my brain around, or concepts, is so if just as a comparison to a process running on Linux. So a process running on Linux. There's a lot of stuff going on in that process, but essentially it's a lot of mechanics that is eventually talking down to system calls.
Right.
And the system calls are defined by, well, in Linux, Linus Torvalds and etc. And in microkernels, it seems like that fundamental bedrock API is is not the Linux kernel system call list, but it's the Zen the whatever. I'm sorry, I don't know the right words.
Hypervisor?
The Zen hypervisor calls. Is this? So I guess I'm not sure why this can't be done as a process. Like, couldn't we take a process and write a compiler that just produced a process that threw out all that other stuff and talked to, a restricted set of system calls instead of having a whole hypervisor?
Well, inside some ways, you're almost, defining a unikernel right there. Let me step back first. First of all, it doesn't have to be Zen. There are a lot of unikernels that rely on Zen because Zen has some really simple interfaces, and particularly ones that don't require hardware virtualization. They use power virtualization, which simplify things greatly. But there are some unikernels that can use KVM, and some of these other ones as well. That's fine. But from your standpoint, let's go from the program standpoint first. Programmer standpoint, does that programmer need to know about the hypervisor calls? The answer basically is no. What in the unikernel world is that rather than you got a call that you want to read something from a disk. In the normal processing, that's handled at runtime. Call goes out, it goes down into the operating system kernel, it calls libraries, whatever, it comes back. In the unikernel world, that happens at compile time. So the code that you need, the libraries that you need, are brought in, and they're there inside the unikernel. Now, those calls that you never make, those libraries are not brought in. They're not there. They don't need to be there because they're unnecessary. And for people who remember, what is it, the Venom exploit of QEMU last summer, I think it was, that was an exploit based on the floppy controller. And it's like, how many VMs are running with floppy controller? I mean, no one's using a floppy controller. But the problem is the code was there. Mm-hmm. And so that hole was there, and no one looked at it. Who looks at a floppy controller? But yet, someone figured out how to get in there and do something bad. Well, in a unikernel, there is no floppy controller if you're not running on floppies. Right. So that door is closed. The Heartbleed thing, where it's like, they figured out the SSH key or whatever. It's like, there's no SSH. I mean, if that's not what the unikernel does, it's not there. So the exploit's not there. So there's a lot of these things that are on the library level or at the kernel level. You look at the list of exploits that go along in the Linux kernel is not insignificant. Those things melt away, and instead you have this very, very thin little stack. And so it's a question of, is there a problem with one of the calls that's used in that particular unikernel that someone can get it?
Right. So I understand you've minimized the code because you've stripped everything down. But I guess stripping down the application's one thing. But what I hear you saying is this lets you strip down the operating system code itself, and also. And also, you didn't mention, I don't think you mentioned this, but it just dawned on me that there's also one fewer change from user mode to kernel mode because there's no, that paradigm doesn't exist.
Yeah, it doesn't exist. And, it doesn't actually pare down the application at all. What it pares down is the operating system. That's it. The fellow who worked to get MySQL running as a unikernel and Nginx running as a unikernel, he was saying, I didn't have to change one line of code. Not one line of code. Where he spent all his time was in the compile. Because now it's going from a native compile to a cross-compile, so he's got to make sure he's bringing in the right libraries that he needs to synthesize, as it were, a working operating system. But from an application standpoint, it's the same application. It's the exact same code base. All that's different is that instead of talking to an operating system layer, he's now talking to this library operating system, which takes it right down into the hypervisor.
Right. Okay. So and just another, because I live for metaphors and analogies, it's linkers used to just basically be like cat. They just kind of concatenated everything, and then they invented optimizing linkers that strip out all this stuff. And this is kind of doing that for the operating system based on what the application needs.
That's as an analogy, I guess.
Okay.
I mean, but best to talk to one of the Unicron developers to make absolutely sure, because I don't want to lead people astray. But yeah, you're taking this gigantic operating system and you're reducing it to just the barest little pieces that are required to get this application to run, and that's it. And when you think, oh, that's not much. I'll pare down Linux. I'll make a lightweight Linux. But then when you begin to realize all the things that are in that lightweight Linux that you don't need. I mean, you don't need virtual memory management on your web server. Right. You don't need multi-process management on your web server. You don't need, and you can go down the list of this huge number of things that, just aren't necessary. You don't need authorization. Why would you need an authorization service? Except for through the web itself. But there's no usernames. You don't need protection codes.
Right,
why?
Right.
It just is what it is. And so if we can pare it down to that sort of essential minimum, do away with all the rest, we can get things that are really small. They start really fast. They shut down really fast, and you can start stacking them like cordwood on a server where we couldn't imagine that before.
So we have another QA that I want to insert at this point in the conversation, and I'm going to summarize it. He had a lot to say, but I'm going to try and summarize it. So Mark basically says he's been working with Docker, Kube, K-U-B-E, I have no idea how it's officially pronounced, and OpenShift. He likes RKT. I assume that's Rocket in the space. It seems that even in that amount of reduction, the first thing people notice is the need to put stuff back to do the management you can no longer do. Basically, he's seeing a lot of pushback from people when he tries to reduce the footprint of things, as you say. Is they push back against Atomic and CoreOS. The second thing people ask after Hello World is, okay, so how do I manage this? Obviously, you're talking an even more reduced, even stricter reduction in available services. So I guess his question comes down to, how do I deal with the users who are pushing back against implementing this type of thing, or the devs who are pushing back against it, or the other sysadmins who are pushing back against it, or management, everybody.
Right. What I would suggest is that unikernels are not a panacea. So you start with the things that make sense. You're not out there to make everything into a unikernel. I think that would be just, at this stage of the game, would be kind of crazy. But there are things that can exist as singular services. That makes sense. Now, for other ones that you want to have all this peripheral augmentation, you want to have all these additional things that can be done, that may not be a good first choice. Start with the low-hanging fruit. Start with the things that can be miniaturized, and there's a lot of them inside the standard data center. I used the illustration during my talk that I knew a fellow 10, 12 years ago now that was building a data center and didn't even have the power in for half of it. And he said, this place is full. And he said, what do you mean this place is full? You don't even have power on. It's like, no, I know where everything's going to go. And when I get every machine in here that belongs in here, this place will be full. I will not be able to add one machine, not one rack, nothing. I said, well, why'd you do that? Why would you build something that's full on day one? And he said, well, because the power company said, this is how much power I have. If you want a lot more, you got to go somewhere else. And we're used to thinking things in the cloud that there's just unlimited resources. But the sad fact is that inside real data centers have limited resources. They need power for machines. They need power to cool things and so forth. They need floor space. They need all sorts of stuff like this. So if we can take just the low-hanging fruit, just start with the DNS servers, the web servers, the things that are relatively well understood and can be miniaturized effectively. Start with those ones. Also, the ones that are going to take the attack from the outside, because they're the ones facing, the great wide world. If we can start with some of those ones, things that we understand, and then we start considering, well, do I really need my database as a unikernel? The answer may be no. Let that thing, do what it needs to do. Or, for you, it might make sense. So, I mean, it's one of these things where there is some thinking that needs to take place. Sure. But in this industry, we shouldn't be afraid to think,
So if I was going to paraphrase that a little bit, you're basically saying that the things we should look at as low-hanging fruit are well-understood services and processes, ideally edge-facing ones that are relatively standalone rather than highly interactive with, for example, multiple processes making up themselves?
That's more or less what I said. I mean, if you talk to some other unikernel people, they may have a different suggestion, but to me, that makes a lot of sense. That if another thing is that unikernels, by their very nature, are singular process. So if you have something that requires multiple processes, you either have to re-engineer so it will use multiple unikernels, or maybe this isn't the thing that you want to be dealing with right now, and leave it the way it is. So, I mean, there are these sort of considerations that you have. But yeah, I think the low-hanging fruit, are those things that we do understand and that we can replicate very easily and do face the web personally.
So I'm gonna move on to one last line of questioning before we wrap up, and that is at the end of your talk, you mentioned that you were surprised to see that even databases could be done this way. Is there anything else you've been surprised by since then?
Oh man, in a lot of ways, the unikernel, everything that's going on in the unikernel world is kind of surprising to me, because we're rethinking things from the ground up. We've never thought of things quite this way before in the data center. Like I said, this is embedded programming, 101 for a lot of it, but the embedded people are over here and the enterprise people are over here. The fact that we've got the databases in there. When I discovered that Unique was released there by EMC a month ago, and I still want to get the details on it, but the write-up on that sounds really intriguing. They've apparently done some work to try to make it easy to take your existing application code and turn it into a unikernel without without extra caffeine, without having any palpitations about it. So I want to understand that more. If that's actually following through on its promise, that is tremendous. But the capabilities, I was thinking initially when I was giving these talks, pretty much solely about sort of like this web edge limited things. But the fact that they've got MySQL and some of these other things out there that are running fine. It's like, dang, this is going to take a while to figure out what fits. People ask me, well, what fits as a unikernel? Well, honestly, I don't know, and no one else knows either. We're still walking down that road. But the things where I thought the lines would be, it's a lot broader than I thought it was. So I mean, we just have to do some thinking. We need to put some feet on the ground. And like I said, people want an opportunity to do something really neat and perhaps kind of earth rumbling. Here you go, man. There's a lot of ground to cover, because we're inventing problems we've never had before, but the end result, I think, is going to be something that we need so drastically, so terribly. We need to up the game. When I was at the O'Reilly Software Architecture Conference in New York City, I'm walking down 7th Avenue, I think it was, and I'm looking at the names on the buildings as I'm walking back. I'm thinking, okay, that one I know got hit. That one I know got hit. I don't know about this one. I don't know whether that means that they didn't get hit or we just don't know about it. This one got hit. We are getting into a dangerous, ridiculously dangerous situation right now in security, because the stuff that used to work in the old paradigm clearly isn't working well in the new one. And so we got to change up the game a bit. And the notion that we can try to eliminate as much of the attack surface as possible at the application layer is very intriguing. Is everything done? No, probably not. But once again, here's opportunity, because we've got something that works. People are working with it. People are doing things with it. In fact, Galois, I think, has some, which was the company that was behind HalVM, actually has security devices, network devices that they now sell. based on this technology. So I mean, it's out there and it's doing some stuff, but there's still so much more thought that can go on. With everyone's listening today, you know, start applying their collective mind to this. I think we can go to fascinating places. You know, I think I've said this before in my talks. That
I think we need to pause here.
Okay.
Running on time. Yeah, take a breath. Let me get a question inserted in here. Actually, that's all the time we have. Thank you very much. So to close, we have our three. I like to call them my actor studio equivalent questions. And are you ready? Are you ready for these? Are quick. These are really quick. Don't think about it. Just answer it. Okay, you ready? What was your first computer?
It was called an Interac. It was sold by, well, actually, it was built by a company that failed before it started selling them. So another company actually started putting them together and selling them in the back of, I think, Kilobaud Microcomputing. It had 16 kilobytes of memory. It was loaded with a tiny BASIC on a cassette tape.
So awesome. Question number 2: have you ever had to press the quote big red switch? That is that emergency power off button that powers off a server room or data center.
Not on a real one. I mean, I'm sitting in the middle of 20 odd machines here, and I've had to do it here once, but not where it counts, thankfully.
And our next question is, who's your favorite computer scientist or author?
I think my vote there probably goes to ESR, to Eric Raymond, for Cathedral and the Bazaar. That, for me, was a very stimulating discussion and really got me charging ahead as an open source advocate.
Wow, well, great. You know, thank you so much, Russ. It was great having you here, and I love your enthusiasm, and I feel like we're really getting in on the ground floor by learning all about unikernel. So thank you so much for joining us.
I greatly appreciate it. Thank you.
That brings us to the end of this month's Lisa Conversation. We hope you enjoyed it. Thanks to our producer, Natalie Descharlet. I hope I got that right. Thanks to all of you and to our guest, Russell Pavlicek. I'm speaking too quickly, can you tell? For joining us.
This concludes our first season of Lisa Conversations. We would like to thank all of our guests and all of you for joining us. So keep an eye on Usenix's website and social media for announcements about our future seasons and projects. This is Tom Limoncelli.
This is Kat Okita.
And this is Lee Damon. Thanks again for joining us, and have a great summer.